The last type of factorizing that we're going to focus on is called grouping. Now, if you have more than 3 terms, you need to consider grouping factorization. Before you even start trying to group your terms, you must, again, just like with trinomials, look and see, have you got a highest common factor, and make sure that you take that factor out of all the terms first. But if we assess the terms that we've been given over here, the A factors are only in term 1 and 3, the B's are only in 2 and 4, the X's only in term 1 and 2, and the Y factors in 3 and 4. So in fact, there is not a single variable that is common to all 4 of those factors. By grouping, what we do is we concentrate on terms in groups. And the way that I've shown over here, I'm going to concentrate on the first 2 terms and then afterwards the second 2 terms. Looking at my first 2 terms, I have a highest common factor of x squared. When I take that out, I am left with a bracket factor of a plus b. Now, keeping my line, I'm now going to be working on the right-hand side of that pink line. The highest common factor that I'm going to take out here is not only just y squared, it's going to be minus y squared. And so the first term that's left over must change sign. As it was minus ay squared, it's going to be plus a left in the bracket. Similarly with the second term, it was a minus by squared. The sign must become the opposite because I took out a minus, so it's going to be plus b. Now looking between these 2 terms, because I've reduced my expression from 4 terms to 2 terms, I can see that there is a bracket common factor between the 2. The leftover factors after I took out that bracket factor of a plus 1 are going to be x squared from the left-hand side of the pink line and minus y squared from the other side. Now remember, I said factorizing is great, but you must always try and factorize fully. And this second bracket factor, in fact, could be split into 2 further brackets. As it is the difference of 2 squares, I'm going to create 2 brackets, one with x plus y and one with x minus y. Let's see if we can do some grouping over here. Now the first thing that I'm going to notice here is that I'm going to group the first term separately to the others. I only do this after assessing that there isn't a highest common factor, and in fact there is not one that is common to all 3 terms. So in this case, I'm going to leave my first term exactly as it is, and in my second and third terms, I'm going to take out a common factor of a minus 1, which leaves me with x plus 1. Now you might have noticed already in the first instance that x squared minus 1 should have been factorized further. If you had done this, then you would have been 1 step ahead of me, because that's what I'm going to do now. So from the first term, I'm going to get x plus 1 and x minus 1. My second term is already a linear factor, and so I'm going to leave it as it is. Now if I draw in my pink line again, you can see between the left and the right of that open minus sign, there is in fact a bracket factor of x plus 1 that is common to both terms. I take it out, and I'm left with x minus 1 from the left minus another one from the right. And now if I simplify that last bracket, I have x minus 2 in my second bracket. So fully factorized, that original expression is now x plus 1, x minus 2. When we look at this example, we could try many different ways to try and factorize this, but I'm going to tell you that you're going to struggle until you recognize that you are going to group it as shown. I'm first going to do a trinomial factorizing for the first 3 terms, and I'm going to leave that last term as it is. Now let's check how I'm going to do this trinomial. This is going to be a plus trinomial, and so I'm going to have to add in order to get to my middle term. Drawing my trinomial cross, I take the coefficient from the first term, I split it at the front of my cross, I take the number from the last term, and I split it at the back of the cross. Now you'll recognize that this is very similar to one that we've had before. When I cross multiply, I have to get the coefficient of minus 6 for my middle term, and so that means that when I add, I'm going to have minus 3, minus 3. Filling in my x's, I have now very nicely factorized that trinomial. When I write it down, though, I'm going to write this down noticing that these two factors are identical as that factor squared, because I had two x minus 3 factors. Now I still have minus 4y squared, and I hope that you recognize now that you have a very nice difference of two squares. In fact, the bracket is a perfect square because its exponent is even. The root of 4 can be found perfectly, and y's exponent is also even. So when I break this down, I'm going to break it into two brackets, one with a plus, one with a minus. I had two bracket factors in my first term, so I split them evenly into the first place of my two bracket factors, one in the first bracket, one in the second. The square root of 4 is 2, and the square root of y squared is y. And so in my second place, I have 2y. As I cannot add any of these terms because they don't have the same variables, my answer simplified will be x minus 3 plus 2y, and then x minus 3 minus 2y. And this is fully factorized.